Welcome to our session in quantitative methods. We're going to start with the first topic. This is statistics for beginners. So I'll be as basic as can be so that you could understand the concepts starting from the first topic. So we're going to review this paper as I take you through the concepts in quantitative methods. So to start with, we're going to look at what is called data presentation. So in data presentation, you need to understand the types of data that we have or variables which are classified in quantitative and qualitative data. So you need to understand what quantitative data is and what qualitative data is. So quantitative data is data that is numeric. It measures how many, how much, how often. It measures numbers, whereas qualitative data measures the types that could be represented by a name, a symbol, a number code. These are what we call qualitative data. So you need to understand that from these kinds of data, you could want to classify them as ordinal or nominal. So let me give you an example. We'll be dealing with, for instance, a data unit, which is a person, and we want to know how many children they have. So if you say 4 children, that is quantitative, it's measurable. But the person, you would want to find out some qualitative data of where they live or where they were born. You can say Zambia, that is qualitative data. A house, for instance, how many square meters it has? 200 square meters. That is a measure, quantitative. In which city that house is located? That is qualitative, Lusaka or Kitwe. A business, how many workers it has? 24. What industry it is? Retail, qualitative. So you also must understand that from the quantitative, we have what we call continuous and discrete. Continuous and discrete. So discrete, we are dealing with information of data that does not have decimals in a layman's language. For instance, 1, 2, 3, 4, 5. But continuous has decimal points like weight. What is the weight? 2.5. What is the time? 1350. All that is what? Continuous. How much volume of water do we have? 2.5 or 2.645. It has decimals. But how many are you in a family? If you have 4, that is discrete. It is countable. Same with qualitative data. We have what we call nominal and ordinal. Nominal and ordinal. So like we were trying to explain our quantitative data, one of them is overlapping and the other one is distinctive. So when you're dealing with a nominal scale, we're looking at variables that are named with no specific order. When you're dealing with nominal variables, we're dealing with variables that have no specific order, whereas ordinal, we're dealing with variables that have a specific order. They have an ending and a starting point. So for nominal, we could also give an example. For instance, tribe. You could be both Bemba and Tonga at the same time, a mixed race. Whereas ordinal is distinctive. You are born in a single place. You can't be born in Zambia and Angola at the same time. So now we go to answering these questions that we have here. So what kind of data do we have? The number of male professors in mathematics department. What is it? This is, what is this? This is quantitative, discrete. Quantitative and discrete. When we go to the country of birth for selected postgraduate, that is what? Nominal, or that is qualitative, ordinal, or just a qualitative. Favorite sport in high school, that is qualitative. Color of one's hair, qualitative. Brand of computer, qualitative. Volume of petrol, that is quantitative. You can measure that. Is that clear? So now we go to what are called pictograms. So in our pictograms, you need to understand the following. A circle that has demarcations is called a pie chart. This pie chart has a total of 360 degrees, like you buy a pie. So if you have A, B, and C, so A maybe is 3, B is 6, and C is 12. You'll be asked to calculate or draw the pie chart from the following data. So the first thing is the total up. What do we get? The total up, 3 plus 6, that is 9. Maybe I put a 9 here. So 9 plus 9, that is 18. So 18 is our total. So to find the compartment of A, we simply do 3 over 18 times 360. So we're going to find the degree of item A. So 18 in there is 20. 20 times 3 is 60. So this is 60 degrees. 60 degrees. So you can label, maybe this is your A, 60 degrees. Then our B will be 6 out of 18 times 360. So 18 to 360 is 20. 20 times 6 is 120. So 120, you put your B there, which is 120. And 9 out of 18, 18 into 360 is 20. So 20 times 9 is 180. So 180 becomes your C. That is how we find the pie chart. So our pie chart looks like that. So you need to know how to break it down. Another key pictogram is what we call a bar chart. A bar chart can be shown by an array of bars like this. Maybe this is your A, which is at 3. This is your B, which is at 6. And this is your C, which is at 9. The same one can be what? Withdrawn, but attached. So this is your A, B, and C. When it's attached, it becomes a histogram. When it is attached, it becomes a histogram. Are we together? So the information that you're seeing there is just on basic knowledge, how to present the data. This is under data presentation. When you draw a line We can call these lines curves. So we have curves that are bumpy. This is called a frequency distribution curve. And we have a curve that is upsloping, which is a cumulative frequency curve. So these are the common curves that you need to know. So there's what we call data. Data is simply an organized pieces of information. You could be given 3, 7, 5, 3, 9, and 20. So the first thing you need to do when you're given such piece of data is to rearrange it. So the smallest here is what? 3. We have another 3. Then we go to 5. Then we go to 7. Then we go to 9. And then we go to 20. So we have 1, 2, 3, 4, 5, and 6 pieces of data. So in these 6 pieces of data, we're going to identify the measures of central tendency and the measures of dispersion. Here's what we call the range. The range is simply the difference between the highest number and the smallest number. It's given by x max minus x min. What is our highest value there? Our highest value is 20. And our smallest value is 3. 20 minus 3, we get 17. Half of the range is called the mid-range. Of course, we don't use it so much in your syllabus. So this is how we find the range. You can only use already arranged pieces of data. Then we also have what is called the mode. The mode is simply the highest frequency. The number that appears the most in this case is 3. We also have what we call the median. The median is the middle value. It's half of the total frequency. So half of n plus 1. Our n is 6. 6 plus 1 is 7. So half of 7 is 3.5. Now, whenever we have these following numbers, you need to understand. 3.25, you round off to the nearest number, it is 3. 3.75, you round off to the nearest whole number, it is 4. But if you have a 0.5, 3.5, you get the number that is appearing there, 3, and the next number, 4. The third and the fourth position, then you divide by what? By 2. So the third and the fourth position, the number that you find there. So in this case, this is position number 1, number 2, number 3, and number 4. So you add, or you get the average of these two numbers. 5 plus 7 is 12. Divided by 2 is 6. So 6 is our middle number, our median. So the median is also called the second quartile. So this is the same as our Q what? Q2. Now if this is Q2, what is Q1 and what is Q3? So Q1 is called the lower quartile. Lower quartile is a quarter of n plus 1. So our n is 6. 6 plus 1 is 7. Then Q3 is 3/4 of n plus 1. So our n is 6. And our 1, when we add it, we get 7. So let's start is, what is a quarter of n plus 1? What is a quarter of 6? What is a quarter of 6? What do we get? One point five. 1.5, isn't it? What is a quarter of 7? Quarter of 7 is 1.75. So Q1 therefore is a quarter of 7. So a quarter of 7 will give us 1.75. So we round off this one to the nearest whole number. What number are we going to consider? The second value. And Q3 is 3/4 of n plus 1. So 3/4 of 7. What do we get? When you get 3/4 of 7, so this is 5.25. So since this is less than 5, the nearest is a fifth number. So we're going to go to our already arranged data here. The second number, which is 3, and the fifth number, which is 9. So these are the quartiles. So our lower quartile is 3, our upper quartile is 9. So the difference between 3 and 9 is what we call the interquartile range. Interquartile range is simply the upper quartile, which is Q3, and the lower quartile, which is Q1. So the difference here is 9 minus 3, which is what? 6. So when we have the interquartile range, the same semi-quartile range comes in, or semi-quartile deviation. So half of interquartile range becomes the semi-quartile range, or the quartile deviation. So half of 6, we get a 3. Now, there's what we call a box whisker plot, which has 5 key parameters. Number 1, you find the lower quartile, which is Q1. Number 2, the second quartile, which is Q2. Number 3, the third quartile, which is Q3. Then the values of X max and X min. So our X min was 3, our X max was 20. So here we have a 3 and we have a 20 there. So we have just from calculating our quartiles, the lower quartile is 3 and the upper quartile is 9. So this same 3 here, so meaning our Q1 will start from here, same 3. All right, it's not always the case, but in this case, our Q1 is simply at the same point where we have our X min. So this is also our Q1, 3. Our Q2 was what? Our median, which was a Q2, we found 6. And our Q3, 9. So here we're going to put a 6. And our Q3, which is 9. Our X max was what? 20. The highest value of X was 20. Now, they would want you to identify what is called an outlier. An outlier is simply what is out of the expected what is out of the expected range. So we are now going to use this formula. From the Q3, we're going to add 1 plus 1.5 interquartile range. From the Q1, we're going to subtract 1.5 interquartile range, IQR. So the 1.5 is part of the formula. So what was our upper quartile? So the shortcut that I would give you is just get the interquartile range first, which we calculated. Interquartile range was 9 minus 3, which was 6. So this is how we found the interquartile range. We simply found the difference there. Then multiply 1.5 to this. When you multiply 1.5, we get a 9. This is called your correction term. 1.5 times the interquartile range, this 9, you add it to this figure here, the Q3. So 9 plus 9, we get 18. Then again, the 9 that we found as a correction term, you subtract it from the lower quartile here. Subtract the 9. So you're going to get -6. So meaning our acceptable range will be within what? -6 and +18. Any number that is outside this range is called an outlier. So as you can see, we have a 20, which is out of the range, which is called our outlier. So our outlier here is 18. I repeat on this one here. Suppose you have your lowest figure maybe as 4, and your highest figure maybe as, here you have maybe 30, and here we have 35. Then you have your box, which is starting from the lower quartile maybe could be 5, and the upper quartile, which would be 15. So the difference between these two is the interquartile range, obviously. 15 minus 5 is what? 10. So you multiply this 10 to 1.5, it's standard. 10 times 1.5 is what? 15. So 15 is your correction term. So to this 15, you add this other 15. It will go and drop up to this. So 15 plus 15 is 30. It will lock up at this point there. Then you subtract this 15 from this lower bound there. So 5 minus 15, we get -10. -10. So you discover that the figures that are outside the range is 35. So 35 becomes your outlier. It carries some marks, so you need to understand how to go about it. All right. Then other measures of central tendency, you'll be given values of X, for instance. You'll be told X, F2, 4, 6, 8. So you'll be asked to calculate the mean and the variance. So the first thing you total up here, 6 plus 6, 12, 12 plus 8 is 20. Summation of X here is 20. Then you square each one of these one. This is 4. 4 times 4, 16. 16 times 16, 36. It is 8 times 8, 64. So when you add this, we're going to get summation of X squared, which is 120. So we have what we call the mean. The mean is called the average. So how do we find the mean? It's simply the summation of X over N. So N, how many figures we have? 1, 2, 3, 4. So we have 4 there. So summation of X here we found as what? 20. 20 divided by 4, we get 5 as a mean. Then we go to what we call the variance. The variance is given by summation of X squared minus summation of X to the power 2. Everything over N minus 1. So here we have 120 minus 20 squared over 4, and everything over 4 minus 1. So you need to take note that this in brackets is different from this big figure here. So 20 squared is 400. 400 divided by 4 is 100. So 120 minus 100, we get a 20 there. 4 minus 1, we get a 3. So when you divide that, the variance will be 6.67. So the symbol for variance, for example, is s squared. And when you square root it, we call it the standard deviation. So using a calculator, you can find the standard deviation by simply square rooting the value of 6.67. So later on, we'll be learning how to use the calculator, because some of you don't even know where the standard deviation formula is, or the square root is. So 2.58 is our standard deviation, because when you square root it, it becomes a standard deviation. Any question?
No. So that's so good.
Is it clear? Evelyn, are we on the same page?
It's clear.
All right. Then we go to what we call the coefficient of variation. It is simply the standard deviation over the mean times 100. Standard deviation over the mean times 100. So here it was 2.58. Then our mean was what? 4. Our mean was 4. So when you divide this one times 4 times 100, divide this by the mean times 100, we're going to get 64.57%. So this is what we call coefficient of variation. So we have done the measures of central tendency and dispersion. The last one is the coefficient of skewness, which is given by 3 mean minus median, or Q2, divided by the standard deviation. So the 3 is part of the formula. Our mean is 4. Our median, from here are the middle numbers. So which numbers are in the middle? These 2. We get the average. 4 plus 6 is 10, divided by 2 is 5. So you put a 5 there. The standard deviation is 2.58. So the answer we're getting here is a negative. The answer we're getting there is a negative. So it means it is skewed to the left, negative 1.16. If we get a positive, it's skewed to the right. So we end here. I'll send you the recording, and I'll send you some work to do based on what we have just learned. And let's say any questions. All right. Have a good day.